स्मार्ट माइंड्स ट्यूटोरियल, सफलता का आपका प्रवेश द्वार।
So let us cover sign test today. So first let's see what do you mean by sign test. So let us write what is sign test. Sign test is one of the simplest non-parametric test that can be used as an alternative to one sample t-test. And this test is performed on pair of observation depending on their sign magnitude Sign magnitude means plus and minus, irrespective of their numeric magnitude. Irrespective of their numeric magnitude. So let us see what is the procedure of this sign test. So let us get started with the procedure. So first let us see sign test for single sample. We will first cover sign test for single sample. So if xi is equal to 1, 2, 3, 4, 5, so on up to n represents the random sample of a population. F of x represents the distribution function of random sample Si. Mu m1 and mu m2 represents the specified value of f of x. Then, based on this, the test of hypothesis in sign test is given as So first let us write null hypothesis. So null hypothesis is always denoted by H naught. This will be either, how can you write null hypothesis? H naught maps mu m1 is equal to mu m2, or H naught such that probability of x greater than mu m1 is equal to probability of x less than mu m2, which is equal to 0.5. Now we have the other type of hypothesis, that is alternative hypothesis. Alternative hypothesis is always denoted by H1. This will be either H1 such that mu M1 not equal to mu M2, and H1 such that probability of X greater than mu M1 is not equal to probability of X less than mu M2, which is not equal to 0.5. Now, since median, how do we denote the median? Mu M1. Mu M1 is the median. Since median of population is drawn from randomly selected sample, then the average of it will divide the sample observation into two halves, where one half contains sample observation below mu M1 and other half contains sample observations above mu M. Now let us see test statistic. So the test statistic that must be applied on sign test is as follows. Number 1, take the difference between xi minus mu mi, where I is equal to 1, 2, 3, 4, so on up to n. Number 2, check whether xi less than mu mi or not. If the result is true, assign a negative value or assign a negative sign to the difference. Else, assign a positive sign. Number 3, if x denotes total number of positive terms, and x minus m denotes total number of negative terms, then for large sample, the test statistic is given by, there is a formula for test statistic, Z is equal to X minus NP by root NPQ. This is for positive sign. And what is this equation called? So the above equation is called as standard normal variate. Standard normal variate, where P is equal to 1 by 2 and Q is equal to 1 by P, that is 1 by 2. Therefore, the above equation can be written as Z is equal to X minus NP by root NPQ, which is equal to X minus N into 1 by 2 by root N into P is 1 by 2, Q is 1 by 2. That is X minus N by 2 by square root of N by 4 minus N of 0, 1. Now after completing the sign test for single variable or for single sample, we will see sign test for paired sample. Sign test for paired sample. So here let us consider two random sample of equal size drawn from two population as xi is equal to 1, 2, 3, 4, so on up to n, and yi is equal to 1, 2, 3, 4, so on up to ri. Let the probability function of random sample drawn from two population be f1 of x and f2 of y. Now let us check the test for hypothesis. Let null hypothesis H0 be H0 maps f1 of x is equal to f2 of y. Now to test the null hypothesis, use the formula. What is that formula? Di is equal to xi minus yi. Here we calculate the difference. If H0 is true, then it can be said that random samples xi and yi are drawn from same population of size 2. Moreover, if the probability of First two samples exceed the probability of second which in turn exceeds the probability of test, then H naught will be H naught such that probability of x minus y greater than 0 is equal to probability of x minus y less than 0 is equal to 0.5. Now for positive deviation, we have xi is equal to 1 if xi minus yi is greater than 0 and 0 if xi minus yi is less than 0. So here xi where I is equal to 1, 2, 3 so on up to n is the Bernoulli variate. Bernoulli variate with p is equal to 0.5. Now since xi is independent, we get x is equal to sigma I is equal to 1 to n xi. That is equal to sigma I is equal to 1 to n. What is xi? Xi is nothing but the sum of positive deviation. So the above equation represents the binomial variate with n parameters. If we consider the total number of positive deviation as k, then under H naught we have probability of u less than or equal to k is equal to sigma r is equal to 0 to k n by r p power r q power n minus r. This is not n by r, this is actually NCR. NCR p power r q power n minus r, where p is 0.5, q is 0.5. If p and q is 0.5, then you will get p1 is equal to 0.5 whole power n, sigma r is equal to 0 to k, NCR. We can denote NCR like this also. N and R in a matrix form. Okay. Now finally coming to the decision. What is the decision? Accept the null hypothesis H naught if P1 is greater than 0.5 at 5% level of significance, else reject it. If the sample is large, then normal approximation to binomial distribution will be z is equal to x minus e of u by root over v into u. That is x minus e of u is np by root over v into u. This is u. What is v of u? V of u is npq. So now we put p and q as 1 by 2. So x minus n into 1 by 2 by root n into 1 by 2 into 1 by 2. That is x minus n by 2 by root over n by 4. Now if value of n is greater than or equal to 25, then the test statistic will be z is equal to x plus 0.5 minus np naught by root npq if x is less than np naught, or z is equal to x minus 0.5 minus np naught by root over npq if x is greater than np naught. Hence the theorem.